All right, today we're going to be talking about rectangles and parallelograms again. Rectangles is our second quadrilateral that we are going to be visiting. Please keep in mind that the first page, and actually it's the first two on here, is just a location for you to go back and kind of streamline your thoughts and recap all the important information. So this is something that you will be filling in after you do the practice in class or whenever your teacher instructs you to. So you'll see that after this lesson, you're going to be able to identify the properties of a rectangle, what makes a rectangle a rectangle. You'll also be able to construct that, and you'll be doing that lesson in class. All right, you're also going to be able to determine if a quadrilateral in a coordinate plane is a parallelogram by using slope, length, and midpoint. Once again, those concepts are never going away, so make sure you know how to do that. You'll also be able to, next page, determine if a quadrilateral is a rectangle by using slopes, lengths, and midpoints. Okay, so we're first going to talk about the characteristics of a parallelogram, in a rectangle, and then go to the coordinate plane and see how do we prove whether they are indeed or not. Okay, so let's flip to your third page, please. It should look like this. First thing I want you to do is you see this first bullet. Actually, before that, it says a rectangle is a special parallelogram. So a rectangle is a parallelogram. It has all of the same properties of a parallelogram and then some. Okay, it tells us all the properties of a parallelogram are also true for rectangle. So pause the video, please, and on your own, list out those 5 properties of a parallelogram that are also true for rectangle. So what makes a parallelogram a parallelogram? You need to have those memorized. So please pause the video. I'm going to do the same as well, and I'm going to list them out. After you've done so, press play and check to make sure you got them all. Go ahead and pause. All right, so hopefully you wrote down these 5 things. The opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and that diagonals bisect each other. We will be learning more specific properties as the unit goes on. So the sooner you learn the beginning ones, the sooner you learn the properties of just a parallelogram, the easier it's going to be as we pile more things on. Okay, so let's get in. There are actually 2 more properties that make a quadrilateral a rectangle. Okay, it's important to notice that all 5 things we just listed are true. In a rectangle, the opposite sides are parallel, the opposite sides are congruent, etc. Okay, but there's 2 more facts that make a specific parallelogram a rectangle. Okay, these only apply for rectangles. Now, a rectangle is a parallelogram with 4 right angles. Maybe some of you knew that. All of the angles are right angles, meaning they are 90 degrees. Okay, so if I look at this diagram, I can put a 90-degree angle in each corner. This still holds true for number 3 and 4 that we set up here. Okay, it said opposite angles are congruent. Well, that's true. A and C are opposite each other, and they are congruent. They're the same measure. B and D are opposite, and they are the same measure. Likewise, the consecutive angles are supplementary. 90 plus 90 is 180. All right, so we haven't changed those properties. We've just made them more specific. Okay, so I can say that all the angles are 90 degrees. Okay, so that is an additional property number 1. All angles are right angles. The second thing, okay, we're talking about our diagonals. Well, we know that diagonals bisect each other, meaning it cuts them into 2 equal pieces, cuts one into 2 equal pieces. Okay, so the halves are equal, but specifically in a rectangle, the diagonals are congruent. Put the symbol, write the word as well. So looking at this example, it tells me that if I have A, B, C, D, and it's a rectangle, that AC, which I can draw here, is congruent to, sorry, it's not perfect, BD. So those big diagonals are congruent. Now let's think even further. Okay, we know characteristics of a parallelogram mean that the diagonals bisect each other, cuts it in half. Still true. We just have now something even more specific. Not only do they cut each other in half, but they're also congruent. So what does that tell us about the 4 pieces of the diagonal? It means that these 2 are, the long ones are congruent and they bisect each other. So each of the little pieces are congruent to each other. Okay, so if I cut into 4 pieces, they are all equal. In a parallelogram, that's not true. It's just, it would be that AE is equal to EC and BE is equal to ED. Here, because it's a rectangle, all 4 equal to each other. All right, pause the video, please. List the 2 additional properties of a rectangle that are on your own. So these are things that are true for rectangle, but not necessarily true for parallelogram, okay? Because there's going to be other shapes that are parallelograms but aren't rectangles. Please pause the video and write them on your own. Okay, now there are 2 properties were that all angles are right angles, or you could say it has 4 right angles, however you want to word that, and then that the diagonals are congruent. Okay, so those are 2 new properties of rectangles. What we're going to do now, actually, hold on. Go ahead and go to the next page. We're going to do this you try on your own. It's going to take a little bit of thought, but you can do it. All right, it says in the parallelogram to the right, if HA, okay, HA being this long diagonal right here, if HA is 12.5 centimeters, what is the measure of PS? So you're finding the measure of PS. And then it also tells us to find the value of each of the numbered angles. So we first need to figure out if this is, well, it is a parallelogram, it tells us, but is it a rectangle? And it is, because we see that, I know this one looks funny, but we have 2 right angles down here. Okay, so that implies it is definitely a rectangle, because if those 2 are 90, the other 2 are going to be 90 also, okay? Because they have to add up to 180, so that means this has to be 90, and that means that has to be 90. So it is a rectangle, so you need to know those 2 facts that we just talked about, all right? So please pause the video, give this one a shot on your own. You can do it. All right, let's talk about the sides first. If HA, the long diagonal, is 12.5 centimeters, all right, I need to find the measure of PS. Well, since this is a rectangle, I know that PS is congruent to HS, SA, that, all 4 of those are congruent. So all I really had to do was take the 12.5, the long one, and divide it by 2. All right, and I got all 4 of those sides with a red dash to equal 6.25 centimeters. Okay, why? Well, the 2 diagonals are congruent in a rectangle, and then when I cut it in half, I get the measure of all the 4 parts. So 6.25 is the answer for that one. Those are and symbols, not plus. Okay, let's talk angles now. Here you had to use your brain a little bit. I started off by working in this middle part right here, and I knew that angle, well, the one across from the 52 is 52 because they are vertical angles. Likewise, I knew the angle, I think that's 3, it's under my marker right here, was 128 because these 2 are supplementary. So I did 180 minus 52 and I got 128. Okay, and then I knew that this one had to be 128 because they are vertical. So from there I had to figure out my side angles. A couple things you could have done. These 2, as we said, are equal. If those 2 are equal, that means that this triangle is isosceles, meaning that these 2 angles are congruent. So what I did was 180 minus the 128 from right here, I got 52, and I divided that by half because both of those have to be equal to each other. And if to check, I could add it back up. 26 plus 26 plus 128 equals 180. All right, so guys, you've got to be using tools that we've learned all year and kind of synthesizing them together to come up with these answers. This is nothing new here. The only thing that's new is about the diagonals, okay? To find 64, I could have done a couple ways. I could have done 180 minus 52, divide it in 1/2. Okay, I could have realized that these 2 together have to add up to 90, which is how I did it, as you see here. So I got 64, and then these 2 are congruent, and this one's the same as well, okay? Multiple ways to get to your answers. Rewind if you need to hear the explanation again. Okay, we're going to talk coordinate plane now. We're going to be given a shape in a coordinate plane, and we have to determine if it's a parallelogram, if it's a rectangle, or nothing. Using slopes, length, midpoint, and that's it. All right, so the first one says use the slope to determine whether quadrilateral ABCD is a parallelogram. So let's start by just plotting our points. So go ahead and do it with me. Okay, there's my quadrilateral. Now, the problem saying, is it a parallelogram? And I'm using slope. Why am I using slope? Well, let's think about the characteristics of a parallelogram and think about what we need to prove. In order to prove something is a parallelogram, I have to either prove 2 sides are Both sets of sides are parallel, both sets of sides are congruent. I could do one side being parallel and congruent, but my directions say just use slope. In order to prove congruency, I'd have to use length. Since I'm using slope, I'm assuming I'm going to prove parallel. Okay, because we know that lines are parallel if what? Slopes are the same. So looking at my quadrilateral over here, I notice I want to try and get AD parallel to BC. So I want those two to have, I'm going to put a question mark. We don't know if it is. That's what we're trying to prove. I want those two to have the same slope. And then I want DC and AB to have the same slope because those are the opposite sides. So is DC, RU parallel to AB? So I'm just going to find the slopes of each and see if they're the same. So let's start with the AD and BC. Okay, so here I'm on D. I go up and over. I went up 1, 2, 3 over 1. So the slope of, my points, I went over 2, I apologize. Up 3 over 2. So AD is 3 over 2. BC, I went up 1, 2, 3 over 1, 2. Okay, so AD and BC are parallel. Good. Don't just assume the other one works. Got to do the work. So DC, this one is a negative slope. I'm going down. Down 1 over 1, 2, 3, 4, 5. So it has a negative slope of negative 1 over 5. AB, going down 1, 1, 2, 3, 4, 5. Okay. Slopes are congruent. That means that this is a parallelogram. Opposite sides are parallel. Since I proved both opposite sets of opposite sides are parallel, I can decide, hey, yes, it is a parallelogram. Okay, and how do I know they're parallel? Because the opposite sides have the same slopes. Do all 4 slope numbers have to be the same? No. Okay, that would just mean I have 4 lines that don't cross each other. All right. Scroll down. You're going to try the next one on your own. I'm going to walk you through the very beginning for just 1 second. The directions say use slope and distance to determine whether it's a parallelogram. Okay, so you could go on here and you could use your own method, but I'm telling you specifically slope and distance. Slope talks about parallel, distance talks about congruency. Since I'm trying to prove if it's parallel and congruent, how many sets of sides do I need to say are parallel and congruent? 1 is a bare minimum. I need 1 pair of opposite sides to be both parallel and congruent. And it does not matter which side you use. They just have to be opposite each other. Okay, so we may use different versions. So please pause this, plot your points, pick a pair of sides to find their slope and find their length, and decide if it is a parallelogram. I'm going to pause and do the same thing. Please try it on your own. All right, take a look. It is indeed a parallelogram. Why? Because I proved that RS and QP are both parallel and congruent. All right, you may have done the other 2 sides, and that's fine. But what I found to be true was when I found the slope of RS and QP, they both reduced to 4, so check, parallel. Okay, and then when I found the length, they were both the square root of 80, so my lengths were equal. So because one side is both parallel and congruent, it is indeed a parallelogram. All right, if you need some more explanation, please rewind. If you need to copy the work, then pause the video, but I'm going to move on. Okay, so now we're going to talk midpoints. It says use midpoint to determine whether it's a parallelogram. So let's think, midpoint why? Midpoint is dealing with your diagonals, okay? What is it going to do? Well, we know that it's a parallelogram if the diagonals cut in half. All right, so we need to find the midpoint. Of AC and BD, and you'll see why those in a second. I should have drawn it first. And decide, is it the same? If it is, then the diagonals are cut in half. If it's not, then they're not. So it's not enough to prove it's a parallelogram. All right, so let's plot our points. A is at negative 3, 0. B is at negative 1, 3. C is at 3, 2. And D is at 1, negative 1. So here's my quadrilateral. It's kind of small. Okay, what we're saying is if you can prove that the midpoints of the diagonals are at the same point, then it means it is a parallelogram because it means the two diagonals cut each other in half. So I have AC and I have BD. So midpoint. All right, I am drawing, and because my drawing is awful, they really do cross right there. All right, so to find the midpoint for AC, up 2 over 6 to go from A to C, so I'm cutting that in half. So I'm going to go up 1 over 3. Do that in black. Up 1 over 3, which puts me right here at 0, 1. Okay, so for D, same thing. I'm going to do slope step. Down 4 over 2. So I'm going to cut that in half and go down 2 over 1. So down 2 over 1 does put it at 0, 1. Okay, so yes, it's they're midpoint. They have the same midpoint, so it's a parallelogram. Because of what that's telling me is my diagonals are both cut in half since they have the midpoint at the same location. Okay, so now we're going to specifically use coordinate planes to prove things are rectangles. So all the properties of the parallelogram and rectangles are the same, plus 2 additional ones. Remember, we can show diagonals being congruent. We can also show right angles. So this first one says use slope to determine whether it's a rectangle. Slope. Once again, slope deals with things being parallel or perpendicular. And perpendicular lines imply what? That is correct, right angles. So in this one, we're going to be looking for right angles. All right, so go ahead on your own and plot the points. Okay, here's my quadrilateral. So we need to find right angles. So what we have to do is first just find the slope of all 4 sides, and then we'll talk about what it means. So let's just go ahead. I'm going to do AB and DC first because I'm going to look at those 2 are opposites each other. Actually, it doesn't really matter, but I'm just going to do them first. So to go from A to B, I go down 1, 2, 3, 4 over 2. Which becomes -2. Actually, I don't need to go in order at all. All right, so I'm going to go from B to C now. So I'm going to go over 1, 2, 3, 4, 5, 6, up 3. Oops, I haven't catch my mistake. Remember, rise over run, so it's going to be 3 over 6. Sorry, I should have gone up and then over. Oops. Which reduces to 1/2. Okay, now I'm going to do DC, so I went up 1, 2, 3, 4 over 2. Okay, notice that A, B, and DC are both going in the negative direction, so they're negative slopes. And then my last one, A to D, going up 1, 2, 3 over 6. Which reduces to 1/2. So when I look at all 4 slopes, I have -2, 1/2, -2, 1/2. What do our slopes need to look like in order to imply perpendicular lines? They have to be opposite reciprocals, and if I notice, they are. Okay, every time it's an opposite reciprocal. So because of that, it's telling me that there are indeed right angles, and they are right here, right angle. So because I proved all 4 angles are right, because anytime the 2 meet, they're at perpendicular lines, okay, because BC and DC have opposite reciprocals, AD and DC, AD and AB, and AB and BC. So therefore, I proved that there are 4 right angles. So therefore, it is a rectangle. Yay. All right. So we're just using what we know about slope, midpoint, and length to help us prove these properties of parallelogram and rectangles. All right, number 5, you are going to try on your own. Use slopes to determine the most precise name. Is it a parallelogram? Is it a rectangle? What is it? Okay, so please go ahead, pause, and try this on your own. Plot your points. All right, and as you can see, it is indeed a rectangle. It also is a parallelogram, but the more specific name is a rectangle because it does have those characteristics of a parallelogram, but it also, more specifically, we can conclude there are 4 right angles because the slopes are perpendicular to each other. All right, so what we did is we found 4 right angles right here. All right, so we have one more problem to do. Let's go ahead and flip the page. All right, and the last one, it says use slope and midpoint to determine the most precise name for the quadrilateral. Okay, because remember, if the midpoint is the same, that's telling you the diagonals cut each other in half. All right, that doesn't necessarily mean that they are congruent, it just means they're cut in half. The slope is what's going to tell us whether right angles are formed or not. Okay, so go ahead, start by plotting your points. Okay, here are my points. Here's my quadrilateral. Okay, that was a bad drawing. All right, since it tells me to look at my midpoints, I can go ahead and find them. To go from D to B, it's actually a straight line down. Okay, the midpoint, the length is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the midpoint's going to be about here. All right, to go from the other way, we're going up then over. I went up 1, 2, 3, 4, 5, 6, 7, 8, 9. I went over 1, 2, 3, 4, 5, 6. So I'm going to go up 4.5. 4.5 and over 3. 1, 2, 3. Okay, so the midpoints are the same for those 2 diagonals. Okay, good. So what that tells me is that it is definitely at least a parallelogram because my diagonals bisected each other because the midpoints are the same. Yay. All right, now I need to decide, is it a rectangle though, or is it just a parallelogram? A couple ways we can do it. We can define the length of the diagonals. That's one way. I noticed the one in green is 9. The other one is 81 plus 36. Okay, I got that by doing 9 squared plus 6 squared. And it's the square root of 117, which is not 9 because 9 squared is 81. Okay, so I see the diagonals are not congruent. I can also do slope. All right, so like the slope of AB is 0 because it's a completely horizontal line. The slope of DC is 0. The slope of my other 2 sides is up 9 over 6, which is 3/2. So slope is 3/2. Slope of BC is 3/2. The slope of AB is 0. And the slope of DC is 0. So what I'm trying to show you is, it does show parallel, so it shows that AB is parallel to DC. So once again, another thing proving that it is at least a parallelogram. Okay, we already saw that because their diagonals bisected each other, but the diagonals are not congruent, and because the slopes are not opposite reciprocals, I do not have right angles. So that's telling me this is a parallelogram, but it's not a rectangle. Okay, a rectangle is a more specific name. So all I can conclude, it is indeed a parallelogram. All right, so on your own, go back, write down fill in that first 2 sheets that I talked about on your own. Okay, fill them in, see if you can do it. If you're not sure, then don't do it yet. Wait till the end of class till you practice. But see what you can do on your own without copying it just from your notes. We are all done.